So we now know that we can use union-based SQL injection to return internal results out via the browser. And we also know that we can use sys.tables and sys.columns to get all the internal object names out of the database. So let's do this. We'll jump up into the URL, we'll close off this string, we'll use a union operator, and we're going to want to get all the data out of the sys.tables system table. So let's do a select, and we already know that we need to select an integer followed by a string. So we'll pick object underscore ID, followed by the column called name, which will be the name of the table, from sys.tables. And then, of course, comment out anything that comes after this statement. Let's now run that. And here are our results. Now we can see amongst all the familiar supercar names, we've got names like make, supercar, user profile, we know of that one now, we know of vote as well. We can also see a few others, things beginning with web pages underscore. There's a few of those. That's part of ASP.NET's default implementation for membership. So we've just been able to extract this data straight out of the system. And that is enormously useful. But of course, as we also know, after that last clip where we looked at the system tables, there is also a system table called sys.columns. So let's imagine that we want to get all of the columns in the user profile table. Now we need to know the user profile object ID. But of course, that should be here in the HTML source. So let's right click and we'll go down to inspect element and we'll expand that thumbnail container element we saw earlier. And here's an ID. So let's double click so we can edit this. And I'm just going to copy out that ID, just like so. We'll close those dev tools. And now let's change this query around a little bit. So we're going to want to select from sys.columns. And of course, we don't want every column. We just want the ones where the object ID is equal to what I have on the clipboard at the moment. So now let's drop in a where clause. And of course, the where clause is going to consist of where the object underscore ID equals what's on the clipboard. And we'll run that. And now we have a different set of results. And we're seeing things like this. First name. Hey, there's a first name column in the user profile table. There's also a column called isAdmin. Now something like that looks kind of useful because now we might be able to start talking about privilege escalation if we can actually set that to true for our record. We know that there's a column called password already. We discovered that by trial and error a little bit earlier on. And we can see a column called last name, and probably no surprise, a column called user ID. So we've just been able to suck all that data out of the system simply by querying system tables. Earlier on we had to guess, but you don't have to guess when you've got access to sys.tables and sys.columns. Now remember, those system objects will have different names in different relational database management systems. So this is for Microsoft SQL Server. So do consider what is the right syntax for the system that you are testing. Now, of course, everything that we see here is dependent on there being a union-based SQL injection attack vector. And that's not always going to be the case. It may be that you can't inject into the right place for a union operator, and it may also be that where the SQL injection vulnerability exists, there aren't actually any records returned. So what if the injection risk is in an update or an insert statement where it doesn't actually return a result, it just executes the query? For that, we need to fall back to error-based injection. So let's move on and take a look at how we can use error-based injection to get this data out, and that's going to take a little bit more creativity.